example number 5. So use the graph to calculate the limits. Now I did say that using a graph does not actually prove a limit, but if all the information, if all you are given is a graph, you can just assume the graph has been drawn nicely enough that whatever it suggests the limit is, that is what the limit is, right? You have to kind of play along. Okay, and so here's our graph. So we'll start off easy, and I'll go through it in full detail, and then we'll do the other ones. It'll get a little bit harder. So I want you to calculate. I'm going to put this in gray because then we're going to mark up the graph with different colors. So for part A, I want to calculate what is the limit as x approaches -2 from the left of f of x. What is the limit of f of x as x approaches -2 from the right? What is the limit as x approaches -2 overall, right? Two-sided limit. And what actually is f of -2? Okay, so now let's go very slowly through this problem. Now, this is the easiest one of the ones we're going to do. So, but I still want to go through it in full detail just so you can kind of see a method that will work no matter what. So let's focus on the left limit first, right? X approaches -2 from the left. Okay, so what I like to do is, here's my vertical line at x equals -2. I know that that doesn't matter, right? The value at x equals -2 doesn't matter. If I'm doing the left limit, actually all of this also doesn't matter. So block that out from your mind, right? All that really matters is this little piece of the graph just to the left of x equals 2, that little highlighted piece. Okay, so now like before, I mark points on the graph, right? So I'm going to mark points on the x-axis that are to the left of -2, and then I mark the corresponding points on the graph. And what do I notice? As x approaches -2 from the left, all of the points seem to approach this point right up there. Now, what are the coordinates of that point? The coordinates of that point are -2, 3. Right. And we know that the limit corresponds to what? It corresponds to the y value of that point. So I can conclude that this graph suggests that the limit of that function is 3 from the left. Okay. So now let's switch to the right limit. So what's different? So now, again, I'm still not, x equals -2, I'm still not considering. But now in your mind, you block out what's to the left, right? That's all gone. Forget about that. In fact, actually, most of this you can forget about, right? Not only do we not care about the stuff to the left, we also don't care about most of the stuff to the right. All we really care about is this little piece right here. Just what is happening near x equals 2, -2 rather. So again, the same thing occurs here, right? I mark points on the x-axis that are close to -2. I mark the corresponding points on the graph, and they all seem to approach this point, the same point as before, -2, 3. And so the y values are -2. The y values are 3. So we conclude, okay, that limit is 3. Good. And so now we can kind of erase our crutches, and now we can see exactly what's going on here, right? So from both the left and the right, the y values both approach 3. What would you say about the two-sided limit? So if I were now to consider, so before I could only consider x values to the left or x values from the right. What if I'm allowed to consider both x values from the left and x values from the right? What would you say? Yeah, it's 3. I mean, nothing has really changed, right? In fact, to say that I'm allowed to consider x values from both sides, that's actually a stronger statement. Right, exactly. So what Shu has said, if I'm allowed to consider x values from both sides, if everything from the left and everything from the right both give me 3, then clearly the two-sided limit should also just give me 3, right? So that's actually a very general principle. I'm going to write that down here. So in general, the limit of f of x as x approaches c is equal to L if and only if, meaning these conditions are the same, the two one-sided limits are also both equal to L. Right, so the original function does have a limit, right? And what is f of -2? How do you determine that? That's as simple as you just look at where the function intersects the vertical line x equals -2 and intersects it at the point -2, 3. So this is again just so because all 4 of these numbers are the same, we said that the function is continuous at x equals -2. But we will learn that, I believe that's next Tuesday's lecture. Or Wednesday, actually, next Wednesday. Okay, so now let's continue with this. Again, same graph. Line up. There we go. Okay, let's make this gray just so we can mark it up. So now let's do essentially the same calculation, but x going to -1 from the left, x going to -1 from the right, and f of -1. So Funmilayo said, so what about if they are different? So that's actually a good question. So what if the one-sided limits were different? So we're actually going to see that in this example. So hold up on that question. That'll actually be answered in just a minute. Because logically, this says that these two things are equivalent. So if these two things are not the same, that means this thing is false. So that means since they're equivalent, this would also have to be false, right? So we're going to see exactly what that means in this one. Okay, so what would you say here is limit as x approaches -1 from the left-hand side. What would you say is the limit? So doing this very quickly, right? If I'm doing the left-hand limit, I draw my vertical line at x equals -1. I forget about the right-hand side, or you don't have to draw this like this. You imagine this in your head. You block it all out, and then you only consider what is happening. Only consider what is happening to the left of x equals -1. And so what would you say? What is happening to all the y values as x approaches -1 from the left-hand side? We're only looking at that green part of the graph. All the y values seem to approach -1, right? They all approach this point down here, and that is the point -1, -1. So this value is -1 here. Okay, so now let's do the right-hand side. So what happens on the right-hand side, right? Again, I do my vertical line. I block that out. I block out everything on the left. Who cares? And then I only concentrate my efforts on just that one little piece on the right, right? Just this little piece right here, just near x equals -1. So what happens now? So I see everyone is saying approaches 1, right? All of those points approach this open circle, and that is at the point y equals 1. All right, so now this goes back to Funmilayo's question. What is the two-sided limit? Does not exist. Right, so that's what we say. We say that if the two one-sided limits do not agree, if they do not match up, we say that this limit does not exist. The two-sided limit does not exist. We don't say equals D and E. We just say, we write it out in English, does not exist. Or you can abbreviate with D and A. D and A is a pretty standard abbreviation for does not exist. Okay. Why does it make sense to say does not exist? Does that agree with our original notion of limit? Yes, because think about it this way. If I'm allowed to consider x values on both sides of -1, consider the following. I look at a value of x to the left of -1, then to the right of -1, then to the left but closer, then to the right but closer, then to the left but closer, right but closer, left but closer, right? So in other words, I'm alternating back and forth between the left and the right sides of -1. What's happening to the y values? Right? I go from the green part to the pink part, green part to the pink part, green part to the pink part. And all the y values, or I'm getting y values that are very close to -1, then y values that are very close to 1. So if you wrote down this kind of sequence of events in a table, you would see y values. You would see y values that were just a bit bigger than -1, then just a bit bigger than 1, then just a bit bigger than -1, but even closer, right? Then maybe something like this. You would see y values like this if you followed this sequence of events. And what would you conclude about the limit? It doesn't exist because the y values kind of just bounce back and forth between -1 and 1. So that's why it makes sense for us to say that, well, okay, if the two one-sided limits do not agree with each other, then we cannot say that the overall limit even exists in the first place, because you would always be able to kind of make this sequence of events where you bounce between two different values. So even though x is getting closer to -1, the y values are just bouncing between two different values, and they're not getting close to anything. And now what is f of -1? I think I already saw that in the chat, actually. F of -1, you literally just look at where is the filled in circle on the graph, and that's at y equals -1. Okay, so just two more quick examples. It's gray. So now we're doing everything at 1. So x approaches 1 from the left, x approaches 1 from the right, x approaches 1, and what is f of 1? Okay, so you can just write it in chat now, since since we're running out of time. So x going to 1 to the left. What would we say the answer there is? 1. Good, right? We're just looking at this green part of the graph. 1. What about x approaching 1 from the right? 3. Good, right? We're only concentrating on this part of the graph up here. What would you say is the overall limit? Does not exist, right? Because why? Because the two one-sided limits do not agree with each other, right? 1 and 3 are not equal. What would you say is f of 1? 2, right? You're just looking for where where the closed circle is. So that would be this pink, and that would be y equals 2. So you can actually see that all four of these numbers, or all four of these answers, could be different, right? That's perfectly possible. And finally, one last example. What is happening at 2? So as I'm writing that out, you can kind of just calculate that for yourself. X approaches 2 from the left. X approaches 2 from the right. X approaches 2 overall. And f of 2. So again, let's do this very quickly in chat. What is the left limit? 1. Good. We only care about that green piece. What is the right limit? More people saying 1. Good. We only care about that right piece. Overall limit? 1. Good, right? Because they're all the same. So this is just equal to 1. And then f of 2 does not exist, right? Because there's actually an open hole here. There's an open hole there. And in fact, if you look, does this graph ever intersect the line x equals 2? No. So the x equals 2 is actually not in the domain of this function. So I'm just going to say here, okay, f of 2 actually does not exist. Or you can say f of 2 is undefined, right? Either or. Okay, so we're a few minutes over, but that's okay. I kind of planned on that since I knew there wasn't a quiz today.